Welcome back to the journey where we explore the deepest corners of existence. This is Earth Beyond, Mysteries of the Universe. We often look at our solar system as a vast home, but it is merely a speck of dust in the cosmic ocean. Today, we venture beyond the familiar into a realm where structures and phenomena exist on scales that defy our human imagination. In this 12th chapter, we witness the titans of the cosmos, entities that shape the destiny of galaxies and time itself. Prepare to witness the extreme forces that govern reality, from the densest matter to the invisible energy tearing the universe apart. Our journey begins with the death of giants. When massive stars exhaust their fuel, they collapse under their own immense gravity. This collapse triggers a supernova, a cataclysmic explosion that outshines entire galaxies, leaving behind a core of incredible density and power. What remains is a neutron star, a city-sized sphere packing more mass than our sun into a space only kilometers wide. The gravity here is so intense that a single teaspoon of this material would weigh billions of tons on our Earth. Some of these remnants spin rapidly, becoming pulsars. They emit precise beams of radiation that sweep across the cosmos like lighthouses. These celestial clocks are so accurate that they rival our best atomic timekeepers, spinning hundreds of times every single second. But among neutron stars, there exists a rare monster known as the magnetar, possessing the strongest magnetic fields in the universe. Their magnetic field is a quadrillion times stronger than Earth's, capable of wiping out data on credit cards from half the galaxy away. When their crust cracks in a starquake, they release blasts of high-energy radiation that can be detected across the visible universe. Leaving these magnetic beasts behind, we approach a region where gravity becomes infinite and light itself cannot escape the grasp. We have arrived at the black hole, a region where space and time are warped beyond recognition by the singularity within. Surrounding the darkness is the accretion disk, a carousel of superheated gas spinning at fractions of the speed of light. The boundary marking the point of no return is called the event horizon. Crossing it means leaving our observable universe forever. If you fell in, tidal forces would stretch your body into a long, thin strand of atoms in a process called spaghettification. Inside, the laws of physics as we know them break down completely. Time stops, and space curves infinitely inward toward the singularity. But black holes are not just destroyers. Supermassive black holes reside at the hearts of most galaxies, including our own Milky Way. They act as cosmic engines, regulating star formation and holding the galactic structure together with their immense gravitational influence. Some of these monsters, like TON 618, have a mass equivalent to 66 billion suns, dwarfing our entire solar system. When two black holes collide, they send ripples through the fabric of space-time, whispering the story of their merger across the universe. Yet all the stars, gas, and black holes we can see account for only a tiny fraction of the universe's contents. Shockingly, visible matter makes up less than 5%. The rest is hidden in the dark sector, dark matter, and dark energy. We discovered dark matter when we noticed galaxies spinning too fast. Without extra invisible mass, they should have torn themselves apart. This invisible substance acts as a cosmic glue, providing the extra gravity needed to keep stars bound within their galactic homes. We cannot see it, touch it, or interact with it, but we detect its presence by how it bends light from distant stars. On the grandest scale, dark matter forms the cosmic web, a vast scaffolding that dictates where galaxies form and grow. It is the skeleton of our universe, an intricate architecture that has guided the evolution of the cosmos since the Big Bang. But while dark matter pulls things together, there is another mysterious force pushing everything apart. We call it dark energy. Dark energy is an enigmatic force that permeates all of space, driving the accelerated expansion of our entire universe. Imagine the universe as a stretching fabric. As it expands, galaxies are carried away from each other faster and faster. Eventually, distant galaxies will move away faster than light, disappearing from our view forever, leaving us alone in the dark. For billions of years, gravity tried to slow the expansion, but dark energy has now won the tug-of-war for the cosmos. This relentless expansion leads us to contemplate the ultimate fate of everything. How will the story of our universe finally end? The most likely scenario is known as the Big Freeze, a slow, cold death where the universe exhausts all usable energy. In this future, new stars cease to be born. The existing ones burn out, leaving behind only white dwarfs and black holes. Trillions of years from now, the last stars will cool into black dwarfs, frozen husks floating in an endless, silent void. Even black holes will not last forever. They will slowly evaporate through Hawking radiation, fading away over uncounted aeons of time. The universe will reach a state of maximum entropy. No heat, no life, no change. Just an eternal, frozen stillness. However, there is a more violent possibility called the Big Rip. If dark energy becomes stronger over time, it destroys everything. In this scenario, the expansion becomes so powerful that it tears apart galaxies, then solar systems, and finally, planets themselves. In the final moments, even atoms and subatomic particles are ripped asunder, destroying the very fabric of reality itself. While these endings are terrifying, they are incredibly far in the future. For now, we live in the universe's prime. We exist in a golden era where stars shine bright, life is possible, and we have the intelligence to comprehend it all. Our quest to understand these superstructures is not just about science, it's about finding our place in this grand design. From the lighthouse beams of pulsars to the invisible grip of dark matter, the universe is a masterpiece of physics. As we continue to gaze upward, who knows what other mysteries are waiting in the dark, ready to be discovered. Every discovery brings us one step closer to unlocking the ultimate secrets of creation, existence, and our destiny. We are the universe experiencing itself, a way for the cosmos to know its own majesty and its own terrifying power. The monsters we fear are also the architects of our reality. Without their violence, we would not be here today. From the first moment of the Big Bang to the final whimper of the Big Freeze, the story is magnificent. Humanity's curiosity is our greatest tool. It drives us to build bigger telescopes and dream of traveling to the stars. Perhaps one day we will not just observe these superstructures from afar, but visit them and harness their limitless energy. Until then, we remain humble observers, piecing together the puzzle of reality, one star, one galaxy, one mystery at a time. The beauty of the cosmos is not just in its appearance, but in the elegant laws that govern its behavior. Mathematics is the language of nature, and through it we can converse with the universe across billions of light years.
Center of the nebula.
Back on our pale blue dot, we continue our lives, often forgetting the cosmic drama unfolding right above our heads. Next time you look up at the night sky, remember that the darkness is not empty. it is full of power. It is full of invisible matter holding us together and dark energy pushing us apart in a delicate cosmic balance. The universe does not give up its secrets easily. It challenges us to think bigger, look deeper, and question everything. We have come a long way from thinking Earth was the center of everything to realizing we are just drifters. But in that realization lies our true greatness. We are the part of the universe that has awakened to understand itself. Is our universe the only one, or are there endless others, each with different laws, different stars, and different endings? That is a question for another time. For now, we marvel at the reality we have in all its terrifying glory. Thank you for joining us on this tour of the most extreme and majestic superstructures that define our cosmic existence. If you enjoyed this deep dive into the cosmos, please take a moment to support our channel for more content. Hit that subscribe